And so what we'll do, I'll run a script. It is going to connect this Android phone and start button mashing random key chords, and so we'll see the screen flash and do a bunch of goofy stuff here. And so it's setting random key chords of Control, Alt, Enter, Shift, and then random other hidden key codes. And what's fun about this is you can have this idea that somebody can be fuzzing my phone's user interface while it's sitting in my pocket is both kind of terrifying, but also hilarious about these bugs, that you can do this forced pairing at the lock screen. You can also do it at the lock screen before the user has signed into their phone.
You can also be victim of this kind of Bluetooth attack. Scary, isn't it? Hello everyone, it's Inan from Industry 404. To introduce myself, I'm a passionate ethical hardware hacker and I popularize the latest vulnerabilities for you. So today I will be talking about a series of 3 vulnerabilities that are named Hi, my name is Keyboard, and that infect all kinds of devices depending upon any operating systems, Linux, Windows, macOS, even iOS. And we'll get interested in why deactivating your Bluetooth when you don't use it will be a smart move. So this vulnerability was introduced by Marc Newlin between 2023 and 2024. You're going to ask me, what does it permit to do? It permits to inject illegitimate keystrokes without user confirmation or user interaction, more commonly known as zero-click exploits. And it can even take control over your device. Is that scary? So how does it work? How is that possible? To answer to that question, you first need to understand how the Bluetooth technology works. You need to know that there is 2 types of Bluetooth technology, Bluetooth Classic and Bluetooth Low Energy. The main difference between these 2 technologies is the power consumption. Here we will only be concentrated on Bluetooth Classic because it's the only technology that's affected by this vulnerability. To dispose of the Bluetooth functionality, a device needs 2 main components, which are the controller and the host. In the controller, which is on a dedicated chip, we have 2 different layers. We have the physical layer and the link manager protocol. The physical layer, which is connected to an antenna, is used to transfer and receive data over the air. The link manager protocol is used to manage connections and security aspects of the Bluetooth technology. On the second component, which is referenced as the host, we have also different layers. We have mainly the SDP, standing for Service Discovery Protocol, which would help, as mentioned, to discover all the different services that are available on the device. Then we have the L2CAP layer. The L2CAP is referenced as being the intermediate between the upper layers and the lower layers. It will help to segmentate, reassemble, multiplex outgoing and incoming packets. And we have different profiles standing for different services, but in our case, we will only have the HIDB profile, which is used to accept keystrokes or clicks from wireless keyboards and mice. Now that you have a better understanding of how the Bluetooth technology works, let's dive into our vulnerability. In a typical use case, when the master device, let's say a computer for example, connects to a slave device such as a keyboard, it goes through the previously mentioned layers. When it reaches the LMP level, it initiates the pairing process. The pairing process is used to authenticate the 2 devices to each other and establish an encryption key that will be used to secure their communication. In this pairing process, various association models are available, offering different levels of authentication and security. You have probably already encountered this when pairing 2 devices to each other, and you were asked to enter the PIN code that was displayed on the other device. But here's the catch. There is an association model which is called no input, no output, also known as just works, that requires no authentication or user interaction. What a wonderful idea, right? This is where our vulnerability originates. Once connected without authentication, a device can get connected to the HIDP profile through the port 17 and 19 of the L2CAP layer. All the devices connected through these ports are treated as a HID device and can input all kinds of commands. Once again, all of that is done without user confirmation or user interaction. Isn't that crazy? So an attacker can exploit this authentication method, impersonate a keyboard, get connected to the HIDP profile, and inject illegitimate keystrokes, and even execute malware to establish persistence. And this is how we get to our exploit. But the question remains, should I be scared or can I get targeted by this vulnerability? The security issues were reported by Marc Newlin to different organizations. Some of them we took into consideration, as you can see on the table, but some of them would remain vulnerable. So my best advice for you would be to update all of your devices to the latest update of the Bluetooth driver. If your device is still vulnerable, my best advice would be to deactivate your Bluetooth when you don't use it. That's all for me, guys. If you have any questions, don't hesitate to comment. You can also subscribe to my channel to stay updated with the next videos. And see you on the next video, guys. Bye bye. Just a last word for those of you guys who have interest in playing with this proof of concept or just checking how it was implemented in the code. I have re-implemented the proof of concept in Rust directly. I'm going to put a link in the description below. You can click on it and just play with it. Thank you guys, see you.